So I got this Insignia, all right, another Insignia Fire TV, and this one is totally dead. That means there's no standby light at the bottom when you plug it in. Right here, that should be blue as soon as you plug it in when the TV is in standby. Absolutely nothing. There's an actual button right up under here. Nothing. Remote. Nothing. Well, other than that, the standby light should be blue right here at the bottom. So let's troubleshoot it and see what's going on. Okay, so on a totally dead set, first thing I will look at or check is my fuse. But obviously we're using a Pico fuse or a soldered in fuse. So for right now, so I have to take the board out and go up underneath the board and do a continuity check. I'm just gonna go straight to my bridge rectifier diode and my capacitors and make sure that I have voltage there. And if I do, that'll let me know that everything from the fuse on up here is good. So I'm gonna plug it in. Okay. Meter is in DC volts. And what I'm gonna do is I'm just gonna go to my capacitor, or I can go on the outside of my bridge rectifier diode and see if I got DC volts. I'm sorry, here we go. Okay, 166 volts and it's steady. I should have that same voltage on my capacitor, right? Okay, 166 volts, DC. All right, from then I can go on and check and see if I have any standby, okay? Because the key point here is if I have standby voltage and it's steady, it's not fluctuating, whether it's 3.5 volts or 5 volts, 5.1, 5.2, then most likely my problem is on the main board. Power supply is working. Okay, so here it has a legend, but nothing says standby. So what I'm gonna do is just check all the pins, all right? And make sure I have a steady, or make sure I do not have a steady standby voltage, 5 volts, whatever. Okay, so I'm just gonna ground my meter, since we're at the secondary side, to cold ground. Okay. That's anything metal on the chassis or a ground on the board. I'm just gonna go right here. If I want to, I can just unplug it from the main board, plug that plug, and check all the pins on it. All right. So this one's color coded. The black ones are probably ground, but nothing, nothing, nothing. Got something fluctuating there. Okay. I don't know what that one is. Nothing. Okay, that's just my meter, period. All right. Fluctuating by itself looks like, but that's in the minus anyway. I don't have any voltage, okay? So, when I unplug it, what I'm going to do, and I have any standby voltage, is I'm going to check and see if I have any drive on the 66 volts. So what I can do is I'm actually going to go to my FET, right? Our main FET, which looks like this, because obviously this transformer here probably uses this FET, but this one actually looks like that's for the LED circuit. All right, and this is the LED plug right here. Okay, so it's pretty much simple power supply. So let me make sure I got voltage right here on my FET, because that means that our transformer probably is good, it's not open or anything, and the FET is probably not shorted. I'm sorry, I'm gonna go to hot ground. I'm gonna go to a hot ground. Okay. All right, I'm gonna plug my TV first before I even do that, and I'm gonna ground my hot ground either on the negative side of this bridge rectifier diode or the negative side of this capacitor. Doesn't matter, either one. Be very careful when you do this, because if you touch the positive side of the capacitor with your hand, or if you short it out with the meter, you're gonna blow something up. All right, because there's still a charge on there. So we can see there should still be a charge on the capacitor. Yes, it was. This one is going down to 19 volts. So, all right. So anyway, let me just plug that in. FET, the drain pin, and now we got 166 volts. Pretty steady. All right. So I'm gonna put my meter on AC now. I'm sorry. AC, and see if I have any drive on that voltage. I have 0 drive. There should be some AC voltage coming up, or I can also go to hertz frequency, right? And I should have something there. I have nothing. So what's happening is the TV isn't getting, or that FET is not getting the drive. That 166 volts is not being cut on and off. So the voltage is steady. The 166 volts is steady, but it's not being driven. Okay, there's no pulse or anything on that. Then lets me know that I may have a drive problem. Okay, so now I have the board turned upside down. Okay, and as you can see, I've got my 50 capacitors, 3 50 capacitors that is marked. All right, these are 3 capacitors right here. So this is the primary side. Primary, this is where our plug comes in at. Okay, and we also have our FET, our main switching FET, and our switching transformer here. Okay, so I don't have any drive on the B plus or the 167 volts that's supposed to be here going to the transformer. So what I want to do now is check the gate pin, all right, which is the pin to the left, is the FET is facing toward me. Okay, so the FET is facing towards you. The pin to the left is the drain, I'm sorry, it's the gate. That's the drain. The pin in the middle, that's going to the transformer. And the one on the immediate right, that is the source, which is usually going to ground through a low value ohm resistor. Okay, so if we look at our gate pin, we can see that we have, looks to be a diode. Okay, so I'm going to check that diode. Do a continuity check here. This is the gate. This is our gate where it says G at, right here. It's going through this diode. All right. So let's check that diode, make sure that's okay. Put my meter in diode scale. It's reading 68 ohms, and there is a 68 ohm resistor in parallel with it right here. Okay, and that is reading 68 ohms. Okay, 680. Remember, reading surface mount resistors, the first 2 numbers are the digits, and the next number is how many zeros to put behind it. I wouldn't say multiplier, because 68 times 0 is 0. So this 0 means there's just 68 ohms. If this 0 was a 1, it would be 680. If it was a 2, it would be 6800. If it was a 3, if it was 683, it would be 68. K, right? 68,000 ohms. Okay, let's look at this one next to it. See, that is 68 ohms. All right. So let's follow this down. This is going here. All right, here's our gate. There's a diode. Resistor in parallel with the diode. All right. Then we have a resistor, looks like. I can't really see that. I think that says 10 ohms, 10R0. Goes back around here and goes up. So this looks like our drive pin. So what I'm going to do is actually plug the TV set in and see if we have any drive here at our drive pin on our pulse width modulator IC. Okay, it's obvious that this is the IC that's closest to the Mosfet. So this is obviously the one that we need to check and see if we have a drive or see if we have BCC. Now, if we don't have any drive, I'm going to look for the BCC capacitor. Okay, which I have one here. So let's relate the capacitor right here. Right there. Okay, that's obviously our BCC capacitor. Okay, so let me just plug it in and put my meter in DC volts, which we had 167 volts. I'm not mistaken. $165 volts. All right, 166 volts. Okay, and my FET, I'm gonna go from ground. I'm gonna go from source to drain on my FET. Okay, I should have the same because source is going to ground, remember? So source to drain, okay, 165 volts, okay? With my BCC capacitor, okay, I actually do have voltage there, but it is fluctuating, okay? So as long as it's not fluctuating low, which means like he should have at least, I would say anywhere between 10 to 15 volts here. All right, so that is fluctuating. And I'm going to put my scope lead on the gate of this Mosfet, okay? Right there. Now that looks kind of weird. So the frequency counter, and that seems pretty low. Let me check this resistor here. Okay, it looks to be 10 ohms. Right below this diode, it says 10R0, which I'm assuming is 10 ohms. And that's reading 8.69 K, okay? So obviously that is way too much. So let's check, the FET actually checks pretty good, okay? Now let's follow that gate once again, which is on my side to my right, this side where it says G, it's marked on the board. I got a resistor going this way, 103, so that should be 10 kilo ohms. Okay. Okay. Give it a check. We got some other stuff in parallel with it. Yeah, 9 kilo ohms, good enough. Okay. Okay, we got the 68 ohms. It's in parallel with this diode. This diode is probably going to read 68 ohms. So it's going to be at the lowest point. All right, and that's because we have this resistor right here, which is 680. That's 668 with no multipliers, no zeros. That's what the zero stands for. 67 ohms. Okay, let's keep going. Okay, we got one that says right here where our diode is coming from. Okay, it's going up to 10 ohms, 10R0. Now that says that's supposed to be 10R0, 10 ohms, and it's reading 10K. Nope, that is going to HS, that's a test point for our drive signal, and that is going right to pin 5 of our pulse width modulator IC, right? Or Mosfet switcher controller, right? I'm just going to take that off. Just take that off. Okay. And I'm actually going to put a 10 ohm resistor on there. I'm going to have to make this very small, so I need to cut the leads on here. Okay. So I had to turn the board around because I'm right-handed. Or am I left-handed? I don't know. One of them, right? So let's go to where that's our diode, and this is our resistor we just took off, R9116. Okay, so I've got my 10 ohm resistor. Okay, make sure that's dry, and then maybe get some tweezers to help me out here so I can push this end up. Okay. Double check and put some more solder on here. Probably gonna move, but yeah, figured that. You hold that in place. Okay. Put some more solder on this one. Okay, looks good. Try that again. Go across here, should read 10 ohms, right? Yep. Come on, stay steady. I don't know why. What's going on here? Okay. So that should read 10 ohms. Yep, there we go. Okay, 10 ohms. Alright. 10 ohms. Okay, as you see, my resistor is not shorting anything out. The leads aren't, I'm trying to say. Okay. So now let's give it a try. Okay, so what I did is I removed the FET because I'm getting a reading of about 200 ohms in between the gate and the source pin. Gate and source. Okay, I removed the FET. The FET is checking good. All right, so I should have like infinite between those two pins almost. And I took this resistor out because I thought maybe the resistor might have got shorted, which I doubt. but I'm still getting 2.0. I did take the resistor out. It is 103, which is 10K, and that resistor is 10K. I put it back in. This diode obviously is reading 68 ohms because there is a resistor next to it that is 68. As you can see, it says 680. Okay, so that is 68 ohms. Okay. I checked everything else. Let's check some of these. Okay, that's 2R0. That should be 2 ohms, if I'm not mistaken. 2R00 should be 10 ohms, maybe. Yeah, 10 ohms. Okay. I'm sorry, 2 ohms. Okay. So the other one obviously was 10 ohms. And the only thing I think of is that diode. Okay, we got some capacitors right here. Let's check this capacitor right here. P9K, so that's obviously 560, 2 more zeros. Yeah, about 56K. Okay, so that's good enough. This capacitor here, 28K. I'm looking for something that's going to read 200 ohms. So maybe it's got something to do with this. Let's see if I can find ground. Well, I know what ground is. You know, on my negative side of my filter capacitor, right here. And I'm going to see which one of these pins right here is going to give me about 200 ohms. The same reading I was getting on the FET. Okay. 61K. To ground. And that's obviously ground pin there. Right? There we go. What pin is this? 134 ohms and 202.94. Where is that going to? Let's see. Going through here. Is this capacitor right here? Let me see. Well, that's going to ground. So yeah, so I'm getting 200 ohms going to ground. Which should, let's check some of this stuff right here. Let's see what we got going. Here's 5R1. That's our 5 ohm. 5 ohms. So this pin here, I guess it's a capacitor. Between a capacitor and I'm assuming whatever pin this is right here to ground, which should be this. That's our 202.96. Okay, so let me see if I can look this IC up. 3S121. Okay, so this is the actual diagram that's being used in the course. And believe it or not, this has the same pinout as this, the pulse width modulator has the same pinout as this IC right here. So we were using on that Insignia power supply board was using a 3S121, and then this one here is a 1S311, looks like a. So pin 6, we're reading at 200 ohms. It's actually the overcurrent protection pin, and that is always going, the overcurrent protection pin or current sense pin, what they may call it, is always going to the source of the Mosfet here, which is obviously going to ground through this 0.15 ohm resistor. But we have a resistor in between, and that says 220. But the problem was that actually here on pin 5, we were getting 134 ohms. So that is too low because that is a drive pin that is going to the gate of the Mosfet. So that looks like that is our problem right here. Pin 5 is the drive pin, and that's why we're getting a low ohm resistance between pin 5. Between the gate and the source of this Mosfet. Okay, as I'm looking here, okay, so pin 1, this is overcurrent protection. So this is our drive overcurrent protection. Let's see what's going on here. And that's going to ground. Pin 8 is ground. That's 133. And that is 200. Voila, flew right off. There we go. So that was our problem, was the chip. Okay, let's see what we got going on the ground. That did go up, 329. There we go, that's our, what's the thing? The drive pin was shorted to ground, obviously. So that was the problem, the drive pin, okay? So that should be obvious because we had that blown resistor on the drive pin. Okay, I'm gonna ground, back to ground, into that drive pin. 9K, and that is 329. I've got my new IC here. Yeah, okay, pin 1 is going to be where you see this dot at right here. Pin 3 is missing. So it can only go on one way. You can't really mess that up, right? Now, unless you're just not paying attention at all, right? Okay, we gotta find pin 1, that's usually right there where the dot is. So it's gonna go like that. Okay, so first let me prep the board. What is that, bro? Yeah, that's kinda weird. All right, hope we don't blow up. And as you can see, yeah, because pin 3 is definitely missing, right? Okay, so let's do some voltage checks, right? So I got my board plugged in. I'm gonna plug her up. So I'm gonna go to my capacitor, my negative side of my capacitor, my bulk capacitor, which should be on that side. And we'll go to my pin in the middle of the FET, which is the drain pin. All right. $165 volts, okay? Now what I'm gonna do with my meter in hertz, okay? And do the same measurement, right? Gonna go to my hot ground, and let's see what we got now. We got 3.2 kilohertz. And obviously it's a frequency, so it's not going to be steady or stable. That is 4 kilohertz. All right, 4 kilohertz, 7 kilohertz, whatever, right? Good enough, right? So now I can probably check the drive on my meter here. This does have an oscillometer. It's not a true oscilloscope, but I should be able to find. First, let me unplug it. If I hit auto, you see I have something there, right? Okay, let's take a better look at that. I always tell you, be careful, because the capacitor still has 127 volts on it, right? And you see it's steady going down. So be very careful when you are handling these power supply boards, even after you unplug it, not to touch anything on the primary side. Scopely, I'm going to put it right there at the drain pin. And let's plug her in. I'm going to hit auto if I can find it. Where we at? Auto set. And that's it. Like what we had on our meter, right? Now, we'll plug it first. Let's go to the gate pin, right? Ensure that we need a signal on the gate pin also. We definitely need a signal there first, right? Before we begin a signal on the drain pin, because that is coming from the pulse width modulator controller IC, what we just changed, all right? Plug it in. And now that's gonna be a little bit smaller, right? So let's just hit auto set. Did I hit it? Let's try it again. Here we go. Right there at the gate. Okay, it says 0 hertz. So, yeah, but anyway, as long as we have a signal there, and when you see it jumping like that, that is good. But I was curious what the standby voltage is on this TV, because I don't see a pin that says standby. The standby voltage is going to be on this plug here, going to the main board, right? And I don't see where it says standby. All I see is 12 volts. Maybe standby is 12 volts. So it's on the secondary side. We can ground our meter over here. Anywhere metal on the chassis is fine. All right, and let's start going through these pins here. 16 volts for standby, looks like. Another 16. 16 there. Okay. So it looks like 16 volts is our standby. All right, because we don't have anything on here yet. But watch, when I turn the power on, look at this signal, it's actually going to increase in duty cycle. Right, it should anyway. So I'm gonna hit power. See, getting it a little bigger, and it's a little fuller now. And now I do have a reading of 64. I'm sorry, that does say kilohertz. All right, kilohertz. My eyes going bad, I guess. that is 64 kilohertz. Right? Let's unplug this again. Want to unplug it. I just want to see what it is without me powering the set on. Want to plug it back in. Yes. It's going between 0 and 60 kilohertz. So that's fine. No big deal there, right? But when I hit the power, now see how big it got? And now we are at 60 kilohertz, 65 kilohertz. So that is about the frequency that you should be looking for on a FET that's switching. And so like I said, if you're using your meter and put it on a hertz function, I don't know, which one is right, accurate enough, but it doesn't matter because we can always visibly check with our oscilloscope. And right, and like I said, you should be getting something there on the drain of the Mosfet. All right, if you put your meter into the frequency range. All right, guys, that's for test of time. Plug her in. Got a solid blue light right here on top. Want to hit the power. Voila, guys. We are looking good. All right, looking good. Most likely, if you're not getting any voltage on the secondary side, including standby, right? That's the plug right here. Okay, we've got a dead power supply board, and you have B plus, what I call B plus, or voltage going across your capacitors, and you don't have any shorted FETs. Most likely, one of the FETs or is not getting a drive signal, or the FET or the IC that is being used for the standby transformer, right? Or for the transformer that is producing the standby voltage on the secondary side. And that's pretty much all it can be, right? So check the gate pin. First of all, obviously check the FET. FET's not sure, the FET's good. Okay, fine. I got voltage on the drain of the FET, but I don't have anything on the secondary side. Look at the gate pin. Check for open resistors. Definitely, number one, check for open resistors. Okay, at the gate pin of the main FET, Mosfet, right? Then check for a drive signal. You saw how easy that was with an oscilloscope. Use your meter and put it on. Make sure your meter has a hertz function. You can even put it in AC, right? Instead of DC, because obviously the pulse is alternating current, right? The drive signal, right? It's alternating doop, 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 doop current. Then just replace, then look at the PWM chip. All FETs are using some type of controller, right? All FETs that are being used to switch a transformer have some type of controller IC at the gate of the Mosfet. Look at the part numbers and get the pin out of the PWM controller and find out which one is a drive pin. But actually, all you have to do is trace the gate pin back and you can find out which one is a drive pin. You're going to go to either a 22 ohm resistor or a 10 ohm resistor. It's probably going to be another low ohm resistor. It's going to be a diode, and I believe that should be about it, right? A service mounted diode, and that's about it. And you can trace it back to the gate pin. And if you're not getting any drive there, use your oscilloscope or whatever, you don't see anything there, then that's your problem, right? I mean, that could be the only problem that you have. All right, till then, guys, I will see you in the next one. Big Dog out.